Hello there, pre-algebra students. I'm glad to talk to you today. I was going to talk to you today about the metric system, and if we were together, we would be picking up some stuff and measuring some stuff to kind of see how it feels. But what I would challenge you to do is go around your house and maybe pick up some of the items that I picked up to take pictures of, just to get an idea of how these different things work, because it's all great to be able to do the math and the conversions, but if you don't have a good sense of what these distances really mean, then it just takes away from certain things. So we're going to talk about lengths. Lengths are all based off of a meter. That should say OFF. Anyway, based off of a meter, or based on a meter would be probably a little bit better to say. Volume is based off of a liter, and mass is based off of a gram. So we're going to start off with the length idea, because really all of the things for all of the different metric system is that they're all based on powers of 10. And when you think about being based on powers of 10, the prefixes all act the same. So if you have the same prefix with different types of metric units, you can do the same type of math with it. But let's get into a few practical examples here. Okay, first of all, you need to understand that there are 100 centimeters in 1 meter. Everything is based off of a meter, and the easiest one to understand is the centimeter-meter relationship, because in our money, we have cents and we have dollars. And cents, there's 100 cents in $1. And really in our English system, or our imperial system, which is the English measure, which is what we measure a lot of things in, like feet and yards and those type of things. In that system, really our money is the one that runs as close to the metric system as we can get. So just so you have kind of a sense of how big of a meter is. Okay, if you go and you find a doorknob in your house, okay, it's probably about a meter high. I'm just saying about because it's not going to be exact, but it's just about a meter high. If you took out a meter stick, if you had one, you'd probably find that it's a little bit off. But just so that you have kind of an idea in your head for, something to compare to, so you've got something concrete. Now what I did is I found a little app, and I downloaded it, and it promptly started sucking the battery life out. So in 5 minutes I lost 20% of battery life. My little quick measurements, I deleted that app because it just wasn't working good, but it did give me a couple of nice images. I had it on my phone destroying my battery life. And what I found is my little beanie baby here, it gave me a nice measurement of 16 centimeters. And my little coffee mug, it gave me a nice little measure of 9 centimeters. So once again, that's something that can give you a little context and be able to see it. Now there are some apps on the phone that, especially if you have an iPhone, there's one on there, but it measures it in inches. And that really wasn't quite what I was looking for, but it is kind of a cool little app if you find that on your phone later and play with it. Just be careful when you download one, you don't do like I did and download one that is going to take all your battery life out very, very quickly. So anyway, it did give us a couple of images and a couple of problems. So how many meters is each object? If there's 16 centimeters, and 1 meter is like the whole, all the way from the floor up into the doorknob, you can imagine, 9, that's very much smaller than that is, and this 16 centimeter little stuffed animal beanie baby, that's very much smaller. So you know that if we're taking 16 centimeters and we're trying to make that into meters, you're going to have to divide that up. You're going to divide it because it's going to be a smaller number. It's only a piece of the entire meter. Okay, there's 100 centimeters in each meter, but this is much smaller than that, so you're going to be dividing So we're going to divide by 100. And when you divide by 100, that moves the decimal place over 2 place values. That's our quick shortcut for dividing by a power of 10. Count the zeros and move it that many place values. So when you are moving that over the 2 place values, what you end up with is 0.16 or 0.16 when you've moved that over, and that's how many meters. Notice that it is a number that's smaller than 1, and that should make sense in your mind because we just talked about, a whole thing all the way from the floor to a doorknob is a whole meter, and this is just a little guy. He's just a part of a meter, so that kind of makes sense. So you want to make sure that once you've done your metric conversion, that think about something in real life to see if that really actually made sense or not. All right, let's do the same thing with this coffee mug. Remember, this is a part of a whole meter. It's, you don't have the coffee mug in front, but you have coffee mugs probably in your own house. So thinking about how far wide across that is, this one measured to be 9 centimeters. And so once again, it's smaller than the whole meter, so we're going to divide by that 100. And when you divide, it moves the decimal over 2 places. Here's our decimal, our hiding decimal, and it goes 2, so you end up with a 0 to fill in. So 0.09 meters. And this is useful because there are some things in science where there are some formulas that when you go up the science ladder, or you might even be dealing with this right now in your science class, or next year if you have physical science, you would have to end up being able to use this measurement. And a lot of the formulas deal with meters rather than centimeters, so being able to convert that over, especially some of these very basic ones, are really, really, really important. Everything is based on a power of 10 when we deal with metric, so you're really only going to be just bumping decimal points left or bumping them right, but make sure that you have a context for it so that you're thinking correctly and figuring out whether you're going to multiply or you're going to divide. Okay? Now let's think for a minute. If you are 1.7 meters tall, how tall are you in centimeters? Well, let's think about that for a minute. Okay, you're definitely taller than the doorknob, so you might actually be approximately 1.7 meters tall. So let's think for a minute though. The centimeters are little tiny units, so there's going to be a whole bunch of them in a meter. There's 100 of them in each one of these meters. So when you're thinking about that, as far as, well, what do I do with that 100? You're probably thinking of, like, there's a whole lot of the little units in the big unit. So that means you're going to be multiplying instead of dividing. So we'll multiply the 1.7 times the 100. And that will move the decimal point 2 places to the right. So what that means is that your 1.7 meter height turns into 170 centimeters. And sometimes that might be useful to you, depending on what it is that you're doing, is being able to make a base unit into the centi version of it. Now this can work with any of the units. It can work with grams, it can work with liters, it can work with any of the metric units. But sometimes it's useful to even think of it in the length context, even if it's a different type, because it sometimes makes it a little bit easier for you to see and understand. Okay, I said based on powers of 10. Okay, if you had a whole big giant meter, there's a next smaller unit, which is a millimeter, and there's 1,000 of those millimeters in a meter. So there'd be 1,000 little tiny jumps from the bottom of the floor up into that doorknob, 1,000 of those. This right here is what you are used to seeing as the centimeter ruler. So 1 centimeter, 2 centimeters, 3 centimeters, depending on how big your screen is, that may be closer or further to scale. But if you notice, each one of them is divided up into 10 little spaces, so that there's 10 millimeters in each centimeter. Okay, so since there's 10 millimeters in each centimeter, that means since there's 100 centimeters in a whole meter, should make sense that since there's 10 each in those, you get 1,000 millimeters in a meter. Okay, 10 millimeters in a centimeter. So let's think through some of these problems right here. So if you have 387 millimeters, okay, 387, and there's 1,000 millimeters in 1 meter, the math that we would need to do for that would be to take your 387 and divide it by 1,000. So that dividing by 1,000 moves the decimal over 1, 2, 3 place values. And then look at your answer and see if it makes sense. So you have 387 millimeters. Well, that's not as much as the number of millimeters in a meter. So you're expecting that it's only going to be part of a meter, which is why you get 3.387, moved it over 3. Let's think about our same 387 millimeters and think about what that looks like in terms of centimeters. I want to think things through a minute, okay? So this would be 10, this would be 20, this would be 30, and 40, and 50. So for each one of these centimeters, there are 10 millimeters. So if we think about it in that way, and you had a number of centimeters, and you wanted to find out how many millimeters that was, you would have to go backwards and you'd have to multiply. But if you knew that you had, for example, 80 millimeters, to find out how many centimeters that is, you would divide, right? So if I had 10, 20, 30, 40, 50, 60, 70, 80 millimeters, I would divide that by 10 to get my 8 centimeters. I want to jump to this one. If I have 4.3 centimeters, that would be the same as multiplying by 10 because you can see the 10s there. So 43 millimeters there. But when we're going backwards from millimeters to centimeters, what you need to do is you need to divide by 10. Okay? So then you need to think it through and see if it makes sense. Well, these are smaller pieces than these. So it should make sense that you have more of the smaller pieces than the bigger pieces. Same with this. Millimeters are smaller. They're the little guys. Smaller than the centimeters. So it should make sense that there are 43 of these when there's only 4.3 of these. You've got a smaller unit here and a bigger unit here. So after you do your multiplying or dividing, ask yourself, does my answer make sense? And that should help you out a lot. If you can always keep your brain around and think, well, does my answer make sense? That's all just a good policy for any subject that you're doing, is always, does my answer make sense? Okay, longer distances. For example, it's not always going to be convenient to talk about how many meters it is to drive to a certain place, to the grocery store or wherever you're driving. In our country, usually say how many miles that is. But if you'll notice sometime, if you're peeking over at the speedometer in the car, they have usually miles per hour, but then there's another part of the dial that shows kilometers per hour. So in most of the other countries in the world, we would be talking about how many kilometers it is. Now, a kilometer doesn't equal a mile, but it's a big unit, kind of like a mile, so that you can think about that. Now, we do have certain things in the United States that we usually think of in terms of metric, and one of them is a lot of the races that are run, especially the shorter ones, is you'd hear, oh, somebody's going to run a 5K or somebody's going to run a 10K. And those Ks stand for kilo. And what they're implying is that they're going to run 5 kilometers for a 5K race. So when we think about that 5 kilometer race and you want to find out how many meters they ran, okay, think about that. There are 1,000 meters in just 1 kilometer. So these are smaller units and this is a bigger unit. So what you should be thinking in your mind is, wait a minute, that would mean that there are more of the little ones than this big one. So I'm going to multiply by 1,000. And we know multiplying by 1,000 moves the decimal place 3 over to the right, which would give us 5,000 meters in this case. So let's think of it backwards. What if you drove 250,000 meters? Okay, that's not going to be so useful as far as thinking about how far you actually drove. But what you can do is you can then think about it in kilometers and say, okay, well, these are smaller than a kilometer, so that means that if I divide it by 1,000 and move my decimal point over 3, that's going to tell me how many kilometers I went, which in this case is 250 kilometers. Okay, so kilo prefix means 1,000 meters in 1 kilometer. So you have to always think, what are the smaller units and what are the bigger units to help you figure out whether you're going to multiply or whether you're going to divide. All right, let's get into some liquid measure. Now, a lot of us think about like 2-liter bottles of soda. That is a common thing that you can get here that is measured in milliliters. This bottle of water, and a lot of your bottles of water, will have 500 milliliters on the label. That's a pretty standard measurement. It could have been any. This just happened to be the bottle of water I had. I do not endorse one water company over another. It just is a good example of where you see 500 milliliters. All right, so if I wanted to find out how many liters this is, okay, there's 1,000 milliliters in 1 liter. There's 1,000 milliliters in 1 liter. So if I want to find out how many liters this is, well, 500 is smaller than this 1,000, right? So we know it's not even a whole liter. So what you need to do is think, okay, well, that means I'm going to be dividing, because this is a little tiny unit. So I'm going to be dividing by that 500 by 1,000. And when I divide that 500 by 1,000, I end up with 0.5, because moving it over 1, 2, 3, 0.5, and those last 2 zeros can be cut off. So you have 0.5, which is a half. This is a half liter. That seems to be a standard size for water bottles. A 2-liter bottle is a pretty standard size for soda here in this country. There are other things. Sometimes you can get a 1-liter bottle of soda. So I actually didn't have one here to take a picture of. We sometimes have soda, but we just didn't have any, so I don't have that for you, but you know what a 2-liter bottle soda looks like. So if you want to think about how many milliliters are in there. Okay, remember, milliliter is a little tiny unit. And just if you want a little context for that, if you look at your pinky finger, and there's a little line, the first line you come to on your pinky finger, if you go halfway up between the little line on your pinky finger, and so you're basically thinking of just the tip, okay, the tip of your pinky finger. If you were trying to figure out how much liquid 1 milliliter is, it's about that much. About that much if you were able to make a little tiny cup that's just the size of the tip of your pinky finger. That would be a pretty close approximation to how much a milliliter is. A little tiny little measurement like that. So 1,000 of those little tiny milliliters are in each 1 liter. So since we've got 2 liters That's a much bigger unit. It's not one of those little ones. So it must mean that there's an awful lot of the tiny ones. We're going to multiply by 1,000. And so when we do that, 2 times 1,000 gives you 2,000 milliliters in your 2-liter bottle of soda. Sometimes it's useful to go the other direction. So how many liters is 25 milliliters? Okay, remember milliliters is the little unit, and you're trying to go figure out how many of the big ones there are. So we know that this is going to be smaller than a liter, so you're going to move it to the left 3 places. And when we move it to the left 3 places, we end up with 0.025 liters. So based on powers of 10 makes the actual calculations just figuring out which way you're going to move a decimal point. Then you want to ask yourself, does my answer make sense? Well, 25 milliliters, yeah, that's smaller than 1,000. And my answer's smaller than 1,000. So I'm pretty sure that my answer is right. And then we get into figuring out mass. Okay, mass has to do with grams and kilograms. So here I've got my 1,000 kilogram, 1 kilogram equals 1,000 grams. That kilo, just like we talked about in meters, that kilo can apply to various different types of units. So a kilogram is 1,000 grams. This particular bag of sugar, it's a 4-pound bag of sugar. You might have a 4 or 5-pound bag of sugar in your closet. The 4-pound bag of sugar is 1.81 kilograms. So if you have 1.81 kilograms and you want to find out how many grams, remember a gram is much smaller than a kilogram, just like a meter is much smaller than a kilometer. That prefix kilo does mean 1,000, but the kilo is the big unit and the regular base unit the smaller unit. So there are going to be more little grams in here than there are going to be with the 1.81 kilograms. So that implies that you multiply by 1,000. Okay, so it should make sense to you. 1,810 grams is 1.81 kilograms. And knowing how many is in one or the other is how you figure out how far to move the decimal points. All right, I will leave it to you to make the little bit of a leap. If we think about milligrams, milligrams is even tinier than a gram. Okay, so you've got all of these different prefixes applying to many different types of measurement. So with all that being said, I hope you have gained a pretty good understanding of these. You're going to work on the assignment to make sure that you've got it, to make sure that it makes sense to you. We are pretty much at the end of the chapter. So once I've released your quiz to you and we've had a chance to go over it and study, I am planning to have you guys take your test on Monday. So please make sure that you're sending in all of the questions that you might have. I want to make sure to do a really, really good review video on Friday for you. So please make sure that you are doing that. And we can go back over anything that you have need of. So you do this assignment, and then tomorrow you're going to be working a little bit more to review, making sure that you send me all your questions by 3 o'clock. And why do I say 3 o'clock? I say 3 o'clock because I don't stay up as late as you guys. So if you're sending me your questions at 10 or 11 o'clock at night, then I have to stay up even later than that to prepare the answers to all the questions. So please make sure that you get your questions in by 3 so that I can spend the early evening time getting them ready so I can go to bed, because I'm old. All right, and us old people need to go to sleep early now. Just kidding. I'm not that old, but I know I'm way older than you. So there's that, and I'm just go to bed early. It's not necessarily a bad thing. But anyway, please get your things in by 3, and I will make sure to include your questions by 3 o'clock on Thursday. Make sure you get your questions in. All right, thanks a lot, and I wish you all of the best and God's blessings.